Hello, hello. Okay, let's get started later. We still have a few students didn't come in. We can have a look at the lecture slides of this week. How is the quiz last week? It's difficult. Okay, let's have a quick look of the slides this week. Probably will help for your preparation for this week quiz. Let me see. I think the first thing we need to have a look is the bands and channels. We need to know how does it work with the channels. Yeah, each channel is usually 20 and 22 MHz. So what does this mean? So what is 20? So which one is 2.4 gigahertz and which one is 5 gigahertz? So you need to figure this out. And yeah, the channel number for 2.4, they have 14 channels in total. And usually we will choose 3 of them like this. Channel 1, channel 6, channel 11, or channel 2, 7, 12, etc. You need to know how to choose the channel because we want them have no overlapping. For example, if we have a lot of Wi-Fi devices in channel 1, 2, and 3, they will overlap together and we will have some like noise and we will reduce the speed and packet loss. So you can have a check what is the channel of your Wi-Fi. So usually our router will select the channel automatically, depends on the surrounding. But you can also change it by yourself. So now you know you need to have a check of surrounding Wi-Fi environment. For example, there are lots of Wi-Fi is in channel 6 and 11. So probably we should put our channel at or something. And what's the next thing? Four-way handshake is also very important. So you need to know what is four-way handshake at first. Why do we need to use it? This one. So we call this congestion avoidance. So we want to avoid the collision in this case, the computer A cannot detect the computer C. And in this case, in the computer B, we can call this one is a host or server. So sometimes the computer A will not know computer C is also connected with computer B, so they can send a packet in the same time to the computer B. And in this case, the computer B will receive nothing because at the same time, computer A and C are sending the packets. So they will drop both of them. So you need to know why do we need to solve this problem at first. And then the four-way handshake is the way how we solve it. So usually we call it RTS and CTS. So it's the congestion avoidance mechanism for Wi-Fi. So you need to know step by step what happened in the first step and second step, just like the TCP handshake. We'll have one more step. And you need to know what is RTS. So why do we need to have the RTS, right? For example, the computer A want to send the packets to B. So why does the computer A need to send the RTS at first? Because the computer A, which is the mobile node, want to make sure there's no traffic from somebody else to the access point right now. So he can send it right now. Otherwise, it will be a collision. So you can have a look at it by yourself. So this slide is quite important. The next stuff is the SIFS. It's kind of calculation in here. So you need to know how to do the calculation in this area. Like it's always related to the time. Let me check if we have an example here. Yeah, this example is the congestion window. We'll have a look of this one. SIFS. So it's just some basic fundamental stuff for the time. Probably we will ask you what is the SIFS for different version of AO 2.11 protocol, but you can get the answer in here. For example, if I'm asking you what is the SIFS for 11G, then you can check this table and figure out the answer. And you can also figure out what is the value for DIFS and PIFS by using this equation. So probably you need to mark this table and it may be useful for the calculation. So page 24. And yes, and here we have an example here. Example, consider blah, blah, blah. So that's the calculation we may have in the exam. So RTS, CTS, and AC. So just make sure you can fully understand why should we use this equation to answer. Especially in here, why is 3 times of SIFS? And what if I change this protocol version to another one? Will we have the same answer? So make sure you can understand this kind of example, because this example is very important to do the calculation. And this kind of graph, you have to know, like, what is this stuff? Because we will always ask you to calculate the time in here. What's the next? It's the power management. Just on theory, just go through them. nothing important, but you need to make sure you know everything here. You don't need to memorize it. Yeah, so the summary in here, you know 2.4 gigahertz channel are using this much bandwidth, and 5 gigahertz channel are using this much, and 2.4 gigahertz are mostly overlapped. So we may test you how to arrange the channels for 2.4 gigahertz channel. So in this part, I have like 80% of confidence that we will test it, because I don't know what will be tested in the quiz, but I will just try to guess. And next part probably will be the calculation for 802.11, including the SIFS. We do have an example in here, right? So you just make sure you can understand that example. And the other thing is about the power saving stuff, but it will not be very hard. Just use the Control F. For example, it will ask you to power saving stuff, then you can do the search, right? Power management. Just search the keyword, then probably you can find the answer for that. For the, yeah, let me see if we have any question here. How about the full address? Full address. Oh, I forgot this part. Full address. I don't know. How can we test this part? This one? It was some serious stuff. I don't know how this part will be tested. Let me think. AP client. Yeah, probably, because this part is still a part of the important thing. Yeah, just have a look of this example. But this part, I don't remember too much about it. Probably will not be very hard about this part. I don't remember we have some calculation in here. And the power saving, yes, will also be tested, because basically, in my point of view, just have a look of the summary. Basically, all the quiz will from this 6 point. I can make sure like at least we will have one question for each point. So I would say, yeah, we will test this part and this part. But for the calculation, reckon is in here. The SIFS calculation for the time. And here for the overlaps stuff. Okay, let me know if you have any doubt. And we can go to the lab for today. Will the main string of AO2.1 be increased? What do you mean by that? I think this week we will test only this PDF. the basics. I think it's only basics. This part. Let me send the slides. I'm not quite sure. You can ask it on the forum because my hub will do this kind of stuff. But I think it's only this one. You can ask him. We will test this one, but I don't think so. But just to make sure, you should post the question in the forum. Yeah, so I write down some review guide in the end of the GitHub link. You can have a look. Basically just the thing we go through. It's the lecture slides and go through the slide at first. And of course, the example are very important. Use Control F, find all the examples, make sure you can understand everything in here. So after you go through the examples, I can make sure you can get at least 70%. Basically, just quite similar question in the quiz. Okay, let's get started for lab 3. So the lab 3 is very easy to do. Basically, just another version of lab 2. Let's have a look. What should we do? So the prerequisites is basically when we need to install the Wireshark, and that's it. Of course, if you are using the Windows like me, then you need to have this one, Microsoft Network Monitor 3.4. Okay, so in the first task, we need to collect 20 files in total, 10 for outdoor and 10 for indoor. Let me show you here. So in here, I have 10 files already. So what do we have inside? I will open one of them. It's just something like this. So it's basically the same stuff as we did in lab 2. As you can see here, we have signal strength, ISSI inside, and the source ID, destination ID, and that's enough. So every file have the similar stuff inside. So what's the difference? You can see the name. The difference is their distance. So when I collect the data, I put them in different distance between the router and the computer. So firstly, I will use my mobile phone to create a Wi-Fi hotspot. Let me do it right now. So I'll turn on my hotspot. You can also try to do it with me. Yep, so I open my hotspot. Then I can use my computer to connect it with it. But I am streaming here, so I will use another machine to connect it with it. So I'm using a Arduino to do it. Don't worry about this code, you will not use it. So this machine is connected to my hotspot right now. Okay, as you can see here. And then I should put them together. So they are very close to each other right now. As you can see, the signal strength is -20, quite stable. Right? In this case, I shall start the collection in Wireshark. So you don't need to worry about the signal strength here, because I just want to show you what is the difference when we do the collection. So in this case, I have connected to my mobile phone. Then I just simply use the Wireshark to start the capturing. If you are using Windows, then you should use the network monitor 3.4 like we did in lab 2. Then after a few minutes, let's say 2 or 3 minutes, then you can stop it and check if you have the signal strength. If you have enough signal strength, make sure you have at least, let's say 50 signal strength that can be used. And then after that, you click the file and then export as CSV. Just save it as 1 meters or something. And then next one, let's do 2 meters. So you need to put your mobile phone away from your laptop. And the distance should be 2 meters this time. So I have just something like this. So the first time we put our mobile phone 1 meter away from our PC. And the second time we put it away 2 meters, and so on and so forth. So we do this 10 times. So it really depends on the size of your room. If your room is very small, probably you can do 0.5 and 1 meters and 1.5 meters and etc. So is this clear for the task 1? Okay, let's go to the next step. So after you have these 10 files, so you need to check before you go to the step 2. In here, I will show how to check. The first thing you need to make sure is how much signal strength do you have inside this one, inside the files. So you need to check if you have at least 50. You can select them in the Excel, and the count is 46. So this one is not enough. So you can try extend the time you collect, or also try to play a video or play a music when you're doing the collection. So it can increase the traffic between the router and the PC. And the second thing you need to make sure is the signal strength, because I found some students may have some trouble when they collect the signal strength here. They always have the same signal strength like this part, but they don't have this part. I think there is a bug for the network monitor that is the signal strength always remain the same. I think it's -60 or something. It doesn't change. So please test it right now and let me know if you have this problem. I think some students may have this problem, like -60 or 60 dBm. So if it's constantly 60, then you need to check if your network interface is working or not. So the first thing you need to check is to use this command to test it. Let me type it. So I send it in the chat. Basically, just open the CMD and type this command. Then you can see the signal strength is in here, 95. And you can type it again, so we can see a lot of SSID. And in here, I can see the signal strength is definitely working in this API, right? Different Wi-Fi have different signal strengths. I can make sure they are both working. Signal. So if this part is working, then which means your network interface is also working, but there must have some problem with your network monitor. So you need to figure out what is the problem with this monitor. So the first thing is you need to make sure you are running this one with the admin privilege. And the second thing is you need to go to the start page and make sure you are only select the Wi-Fi, and there should have no Ethernet or other cable connection, okay? And when you do the collection, then you need to make sure there are only one connection with it. So disconnect with other connection first, and then do the collection. And if it's still not working, probably it's something like library error. So you need to have a check of the library we have mentioned in the lab 0. You need to check if have you installed this one, mpcap libraries. Where can I find it? I couldn't find it. So just install this one, the mpcap libraries. Search and see, reinstall these libraries and reinstall the software you are using. Yeah, so this is how can we try to solve it. But if you still have this problem, probably you need another computer or something, because this one is not working. You can try another computer. If you have Raspberry Pi or other old computer, you can try it. But that's the task 1. And let's go to the task 2 right now. For the task 2, we are going to plot this kind of stuff. At the end, I give you an example in here. So you need to plot this kind of stuff. What is this dot? It's the signal strength, right? And the x-axis is the distance. And we are using the log to calculate the distance. So I just put it here. As we mentioned here, how can we do the calculation? The x-axis, should you use the log to calculate it? So it's not pretty hard to get this out. Let me just open my Jupyter notebook. And I can show you how to get this done. Give me a minute. Here. So we already have the CSV files in here. We already have the CSV file in the folder. So I'm just simply using the pandas to read the CSV file at the first. But then I apply a filter because I only want to have a look of the wireless packets and the signal strength stuff. So you can see here are the signal strength packets after I apply this filter. Then I just extract the information from the sheet in here, right? So basically you can see I have the signal strength with the distance in here. So I just repeatedly do the same thing to these 10 files. Then I can calculate the group by, or you can use the group by function to calculate for each one, how many distance do I have? So how many signal strengths data inside the files do I have after I apply the filter? So I need to make sure everyone is larger than 50. So I can go to the next step. So after I confirm the count is enough, then I can plot it. So simply use the scatter plot. The x-axis should be the distance and y-axis should be the signal strength. So it's not really hard to plot it, right? Just simply use the data frame.plot function. And next step is the draw a line inside of it. So how can we draw a line in the graph? Just use the regular expression or something. It's regression in here, but I recommend you to use this equation here. This one, wholly fit. So NumPy have this function that can easily help you to calculate this equation. As you can see here, the signal strength is changing. So how could this happen? You can see here, when the router and the PC are close to each other, it's minus 19, right? So now I put it away, 1 meter away, 1 meter away. So it become minus 50. And I move it further. So it's minus 55 or 60. Sometimes you can see minus 60, right? As you can see, if we are moving away, the signal strength will decrease. So that's how it goes. We should have this kind of downtrend data. So if you do not figure this, if you have another answer for that, probably you have some problem when you collect the data. So the key thing is you need to maintain the same environment. For example, if I am putting my computer and mobile phone on the table, which is 1 meter high, 1 meter high, then I should always maintain the same height, and there should have nothing between them. So this one is just my output. You may have different one, but they should have like similar pattern. So in here, I will not share my code, but you can have a look of it. You can get an idea. I want you to do it by yourself. How to have this one. So you can type the code by yourself. You can have a look, have a screenshot. But the main idea is to use the NumPy to calculate what is the M and B. Just some regression. You don't need to calculate by yourself. Or you can use the Excel to do this thing. Okay. So if you forgot how to do this, you just come to the recording. I will upload the recording to the YouTube later. And another thing we need to check is the outlier in here. As we mentioned in this part, we can consider one point as our outlier. This one. So what is the outlier? I can show you my example. So when I do the collection, you can see the outlier in this part, this part, this part, and this part. So why I call this part is an outlier. So as we can see here, this part, because we can see the trend from distance 1 to this 1 meter to 7 meter, right? The signal strength is decreasing. But when we come to here, 8 meters, the signal strength increased. This is because I didn't maintain the same height when I do the collection. So you need to avoid this kind of situation. But you do find a outlier like me, you can delete it from the regression equation. So I will just drop these 3 from my equation, or I will drop these all 3 data from my data sheet. So when you do the collection, just be aware of that. You need to always maintain the same environment. And that's it. Yes, for example, when you do in the indoor stuff, you can always put it on a chair. Let me see. So always put your mobile phone on a chair, and you can put the PC on the table, and you do not move the PC. You just move the mobile phone. So you put it on the chair and move the chair, so you can always maintain the same height. Or you can put it on the ground. And it's the same when you do it at the outside. So when you go to the outdoor, you can put it on the ground. Okay, so you have this kind of output. So I will just give you the idea of how to do it, but you should have a carefully look of the specification in this part, what to submit. So you need to make sure you have everything, like 10 CSV file, 10 for indoor and 10 for outdoor. And the CSV file should have only necessary information, only the time RSSI or other information that you think is important. So in my table here, I will show you. It's not enough. So my table is like this. But before you do the submission, you can delete the IP address and the protocol and the length, because this kind of stuff is not useful, right? You can delete it. You can just delete this kind of stuff and also apply a filter. We don't want this kind of packet. It doesn't contain any information. So just do the filter by yourself. And we only care about the useful information here. So your table should looks like this. Just strictly follow the specification here. You should also submit a report for the PDF file. Something like this graph and this equation. And also make sure this one is distance log. And also write down a paragraph about it. So what is your observation? Okay, let's see. What question do we have? Do we need to maintain the same height? Yes. We can use smaller distance, right? Yes, you can. So especially for indoor, you can put it like 0.5 meters, 1 meters, 1.5 meters, 2 meters, etc. But we just need to have like 10 different distance. But when you do with smaller, distance, you can check to make sure you have the correct log distance in here. In here, the log distance, and use the calculator to calculate this one. So log 1 is 0, right? So you need to calculate this one by yourself. We also need to maintain line of sight for PC. It's very difficult. So why it's very difficult to maintain line of sight? You can make sure there's nothing between the mobile phone and laptop. For outdoor, I think I wouldn't be able to move my PC outdoors. Okay, so if you are using a desktop, try your best. Yeah, so if your laptop is not working, you can mention this one in your report. But why how could this happen? So you are using the desktop. Another way to solve it is to use the Windows API, as I mentioned to you before, right? It's this one. So you can simply run this command, this command. So now it's 95, 92. Just repeatedly run this command, then you can get the value. Can you see that? It's 92 right now. So we can use this command to do it. This is very weird. So this kind of stuff will be in lab 5. We will going to teach you how to use the API, but if you couldn't do it right now, probably you want to have a look at it by yourself. Basically, just call it with Python or something else and extract the signal data outside to the CSV file. Yeah, but I still recommend you to use the Wireshark or the network monitor. I think it's the library problem, I reckon. Because if your interface API, your Windows API is working, then you should be able to use the Microsoft Network Monitor. You should have no problem with it. I think it's the library problem, I guess. Okay, I see. Yes, for some reason it doesn't work.
Hey, Rui, is it okay if I can unmute my mic?
Yes, of course.
Okay, solid. Yeah, just to give you a quick overview. So I'm running a Windows 11 system. It's fully up to date. I can assure you of that. I'm also running Windows Network Monitor as an admin. I've turned off the other Wi-Fi interfaces. I entered in the code that you just sent across into command prompt, so my Wi-Fi is working fine. I just keep getting 60 from my laptop opposed to my PC, which is showing varying RSS.
Yeah.
So in this situation, obviously we have to submit them something for the external environment as well.
Yes.
I can't carry my towel outside and try and move it around. Like, that's going to be a disaster. So
Yes.
what do you recommend I do?
Do you have any like other computer that you can try? Because you're pretty close to the answer, right? But I'm not sure like why your network monitor is not working.
Yeah,
So
I've got no clue. I mean, I've got MP-cap installed on my machine as well. I've got it all there. Yeah.
It's still not working, right?
No, still not working.
That's pretty weird. But I reckon if you have a like dongle, Wi-Fi dongle, probably you still not working. I'm not sure about that. But if you have it, you can have a try. But if you don't, probably use this method.
Okay, so just to confirm, basically put my laptop down, call this command on Windows terminal, and then conduct a test, and then sort of measure the signal strength, and that's it.
Yeah, you can do via this way. I mentioned this part in your report. You can say, you have talked to me, and because I may not be the person that mark your submission.
Sure.
But let me know.
I'll do that then.
I'm not pretty sure why we have this problem. We have another student have the same issue.
I know. Yeah, I was in the previous tutorial. I think what you were doing was getting that person's Raspberry Pi working with Linux. I actually have a Raspberry Pi myself.
Yes.
Yeah. So I could try that if you wanted. It just sounds like a huge headache though to get this working. With getting a huge OS onto my Pi and then getting Windows Monitor installed and stuff like that.
Yes, I know. So you can try this one by yourself. See, like, I'm not sure. Probably reinstall it, and see if it's working or not. If it's not working, then you can choose to use the Windows API, or you can use Raspberry Pi. If you are using the Raspberry Pi, you need to install the Kali.
Yeah. Okay. Understood. All right. I'll look into that then. I think what will probably happen is I'll end up using the Windows API, to be honest with you. But I'll try my best. Okay. Yeah,
because this one is very important. You need to get it. Otherwise, you cannot do the following labs.
Yeah.
So especially for labs 4, lab 3 and 4. Yeah.
I can use my tower. I mean, I can use my tower and conduct the indoor tests. I
Yeah.
just can't do the external. That's all.
Yeah, that's it. But I think that for the outdoor stuff, lab 4 will not have the outdoor stuff.
Okay.
But I'm not sure about the assignment.
Okay.
So it's best to solve it this week.
Okay.
So just let
Understood.
me know if you couldn't figure this out. Just send me an email so I can discuss with my other tutors.
Yep, can do. Okay. I'll try and get it sorted. I'll ask you this question. Is it okay if I can use my PC and just conduct 20 internal tests opposed to doing 10 internal and 10 external?
Yeah,
Is that okay with you?
that's fine. That's fine.
Okay.
So you
right,
can
so-
mention that in your report.
Okay. Well, because that at least that way we have something. We have some sort of recording using Windows Network Monitor opposed to, my laptop.
Yeah. Okay. Just try to fix your desktop effort or laptop at first.
Sure. Okay. Will do. Thank you.
Okay. Yep. And that's it for our lab 3. So basically 10 for outdoor, 10 for indoor. And one graph and calculate use the regression to calculate the slope. And one paragraph about the observation. And that's it. So I put everything in the link here. Just let me know if you have trouble. Yeah, double confirm 250 is enough because the requirement says at least 200. Yeah, because in here, we mentioned that for 1 minute, usually we can have 200 to 600 ISS data. But based on my observation, especially for Windows, usually we will have only 20 or 30 packets that have the signal strength for 1 minute. So try your best to capture more data. So if we have 200, that would be excellent. Okay, so make sure if you can capture 200 packets, because we want you to have more packets. So usually we will collect 200, but sometimes we do, like, let's say we have only 150, that's fine. Just try to capture more packets so we can get the accurate answer. Yes, because in here we mentioned that we need to have at least 200 ISS data. But sometimes we do have some like empty packets that do not have the signal strength. So that's the reason I didn't say that we have to have 200. But if you can, if you have this time, please do that. Because for some computer, it's really hard to capture 200 packets. It may take like 10, 20 minutes. Just let me know if you have the trouble in the report. You can mention that, for example, I have tried to capture more, but I can only capture, let's say, 5 packets every minute. So usually we will have at least 30 packets contain the signal strength. Okay, that's basically all the thing for lab 3. If you still have any trouble, just let me know. You can stay here until the end. I will stay here and help you. And feel free to share your screen. So now I will stop the recording.